Mars rovers have begun to investigate surface clues that point to recent water activity. Dark streaks known as recurring slope linii, RSLs, have been observed on Martian hillsides, appearing and disappearing with the seasons. Initially thought to be caused by briny water flows, the current interpretation leans toward dry granular flows. But the debate is still ongoing. Regardless of their origin, the seasonal nature of these features hints at active processes occurring today on Mars. Furthermore, the detection of methane in Mars's atmosphere remains one of the most intriguing modern mysteries. Observations show that methane levels fluctuate with the seasons and even spike in localized areas. Because methane is destroyed by ultraviolet light within a few hundred years, its presence suggests a contemporary source, either geological or biological. If it's biological, even at a microbial level, it would mark one of the most significant discoveries in history. This is why missions like Perseverance and ExoMars are so vital. Equipped with instruments capable of detecting organic compounds and analyzing soil chemistry, they're searching for signs of past or present life in some of Mars's most promising locations. Meanwhile, orbital missions continue to scan the planet's crust, mapping subsurface anomalies and seeking out ice-rich regions that might one day support human explorers, or harbor something more ancient. At Infinity Beyond, we look at Mars as a world of potential just beneath the dust. A planet where ancient environments may have given way to hidden, enduring oases of warmth and chemistry. Mars might seem lifeless on the surface, but nature has shown us time and again that life finds shelter in the unlikeliest places. And if there is still life beneath the Martian surface, even microbial and unseen, then Mars is not just a fossil world. It is a living one, quietly enduring, waiting for us to discover its secrets. Mars is more than just the red planet. It is a canvas on which humanity projects its deepest hopes, fears, and questions about life, survival, and destiny. At Infinity Beyond, we see Mars not as a dead rock in space, but as the gateway to answering some of the most profound mysteries of the cosmos. So far, our robotic emissaries have uncovered evidence of an ancient world shaped by water, volcanic activity, and possibly a once-thriving atmosphere. We've seen clay-rich sediments, river deltas, and minerals that could only have formed in the presence of liquid water. We've measured methane plumes, examined ancient lake beds, and peered deep below the planet's icy crust with radar, all pointing toward a complex and dynamic history. Yet, for all that we've learned, the most important discoveries may still lie ahead. The Mars Sample Return Mission, a collaboration between NASA and the European Space Agency, aims to bring actual pieces of the red planet back to Earth for the first time in history. These carefully selected rock cores, gathered by the Perseverance rover, will undergo detailed analysis in Earth-based laboratories, with tools far more sensitive and accurate than anything we can currently send into space. If microbial biosignatures exist, fossilized or chemical, we may soon have the ability to confirm them beyond doubt. That confirmation would represent a watershed moment in science. It would prove that life can originate independently in multiple locations across the universe, strengthening the argument that life is common, not rare. The philosophical impact would be even greater. It would force us to reevaluate our place in the cosmos, not as the sole bearers of consciousness, but as one thread in a vast, interconnected tapestry of life spread across galaxies. But even if no evidence of life is found, Mars still holds immense value. Understanding how and why Mars changed from a habitable world to a frozen desert can teach us crucial lessons about Earth. It provides a real-world example of planetary climate change, atmospheric loss, and geological evolution. Mars reminds us that habitability is not a given. It is a temporary, delicate state, one that must be protected. The red planet also serves as a proving ground for future exploration. Every mission we send tests our ability to operate in extreme environments, develop autonomous technologies, and push the boundaries of engineering. Rovers, orbiters, and landers are more than scientific instruments. They are training wheels for eventual human presence. And make no mistake, humanity's future will include Mars. Whether it takes 10 years or 100, a human will one day step onto the Martian surface. That moment will be more than symbolic. It will be practical, emotional, and transformative. It will signal that life from Earth has extended its reach, that a new chapter in the human story has begun, not just on another planet, but in a new epoch of exploration. At Infinity Beyond, we believe Mars connects the past to the future. Its ancient rocks whisper of times long gone. Its modern mysteries provoke the minds of scientists and explorers. And its potential as a new frontier ignites the imagination of generations yet to come. So we continue the search. We launch new missions. We analyze every dust sample and photograph every crater. We listen for chemical whispers and read the stories etched in sediment. Because somewhere on that cold and dusty world may lie the greatest revelation of all. Not just about life elsewhere, but about ourselves. Leaving behind the dusty plains of Mars, we now set our sights on the true giants of the solar system. Worlds that are not made of rock, but of gas and ice, pressure and storms. At Infinity Beyond, we consider this the gateway to a vastly different chapter of planetary science. Welcome to the realm of Jupiter. Jupiter is not just the largest planet in our solar system, it's a planetary titan. With a diameter of over 142,000 kilometers, nearly 89,000 miles, it could fit more than 1,300 Earths inside it. But Jupiter's size is only part of what makes it fascinating. It is a planet of extremes, an alien world whose atmosphere churns with immense storms, whose magnetic field dwarfs that of all other planets, and whose family of moons includes some of the most promising places to search for life beyond Earth. From a distance, Jupiter dazzles with its bands of red, white, and ochre. These bands are massive belts of high-speed winds flowing in opposite directions, encircling the planet like ribbons of cosmic energy. Between them rage enormous storm systems, the most famous being the Great Red Spot, a swirling anticyclonic storm larger than the entire Earth, which has been raging for at least 400 years. Unlike the terrestrial planets, Jupiter has no solid surface. Its atmosphere deepens gradually into a supercritical fluid, neither liquid nor gas, under immense pressure and heat. Beneath that may lie a core of heavy elements, but even that remains uncertain. The deeper you go, the stranger it gets. Metallic hydrogen, electrical storms, crushing forces that science can barely replicate. Jupiter is also the solar system's protector. Its immense gravity serves as a gravitational shield, deflecting or capturing many comets and asteroids that might otherwise threaten Earth. This protective role may have been crucial in Earth's early history, allowing life to flourish in relative stability while Jupiter swept the solar system clean of dangerous debris. But perhaps the most intriguing aspect of Jupiter lies not in the planet itself, but in its moons. Jupiter is orbited by at least 95 known moons ranging from tiny, asteroid-like bodies to planet-sized spheres. 4 of them, the Galilean moons, Io, Europa, Ganymede, and Callisto, are worlds unto themselves, each with unique characteristics, mysteries, and potential for life. Among them, Europa has captivated scientists more than almost any other moon in the solar system. Europa is slightly smaller than our moon, but beneath its icy crust lies a vast global ocean, possibly containing twice as much water as all of Earth's oceans combined. At Infinity Beyond, we often refer to Europa as an ocean world, one of the most likely candidates for harboring extraterrestrial life, not on the surface, but in the dark, salty depths beneath its ice. In the coming years, NASA's Europa Clipper mission will embark on a detailed study of this enigmatic moon. It will orbit Jupiter and make dozens of flybys of Europa, scanning for signs of habitability, measuring its ice shell, magnetic field, and potential plumes of water erupting into space. These plumes could provide direct access to the ocean below, a rare opportunity to sample another world's subsurface ocean without drilling through kilometers of ice. Back on Jupiter itself, NASA's Juno spacecraft has been orbiting since 2016, collecting high-resolution data on Jupiter's gravity, magnetism, atmosphere, and auroras. Juno has already revealed that the planet's belts extend far deeper than previously thought, and that Jupiter's poles are home to swirling cyclones, unlike anything on Earth. At infinity beyond, Jupiter represents a threshold, a world that challenges our understanding of planetary formation, chemistry, and even biology. It is not a place we will ever walk upon, but it is a place that has shaped everything around it, and perhaps sheltered the very origins of life.